Well, hello there, and welcome back for another Advent of Code puzzle. So let's go to adventofcode.com, and I know it's already past Christmas, and I haven't finished even half of the puzzles, but you know, it is what it is. Let's continue on where we left last time. This will be day 12, hill climbing algorithm. Isn't hill climbing an actual algorithm? Let's actually search for that. Hill climbing algorithm. Well, I have Spanish results. Can I go to Wikipedia in English? Oh, here. It was right there. Hill climbing. Numerical analysis, mathematical optimization technique, which belongs to the... Okay, yes, it's a local search thing. It's kind of what I imagined, where you search for local maxima. I wonder if that is what we are going to implement, or if this is just a red herring of a title. Okay, so let's see. You try contacting the elves using your handheld device, but the river you're following must be too low to get a decent signal. Okay. Okay, so we need to go higher. You ask the device for a height map of the surrounding area, your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square of the grid is given by a single lowercase letter, where A is the lowest elevation and B is the next lowest, and so on up to the highest elevation, Z. Also included on the height map are marks for your current position, S, and the location that should get the best signal, E. I guess start and end, okay. Your current position S has elevation A, and the location that should get the best signal E has elevation Z. Okay. You like to reach E, but to save energy, you should do it in as few stops as possible. During each stop, in as few steps as possible. During each step, you can move exactly one square up, down, left, or right. Okay, so that is squares here. To avoid needing to get out your climbing gear, the elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you could step to elevation N, but not to elevation O. This also means that the elevation of the destination square can be much lower than the elevation of your current square. Okay, so it is at most higher, and very interesting to read about your climbing gear that you're carrying, apparently. I hope that is some foreshadowing. It's also very curious that you can go much lower than you're currently standing on without using climbing gear. It's like, what are you doing? Like, you're jumping off a cliff or something. That doesn't seem very realistic, but okay, let's... It's not that like realism is usually part of these puzzles. So here's an example. This would be the starting position and the height map, and this is the end. And okay, there's a Z square besides the end square. Here you start in the top left corner. Your goal is near the middle. You could start by moving down or right, but eventually you'll need to head towards the E at the bottom. BC. Oh, look at that. E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X. X? Where is the Y? W, X. Then there's a Z here. No, it's triple X. X, 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 Y, Z, and E. Okay. So you have to go in sort of a spiral, it seems. It's a mountain with a spirally path towards the top. Okay. yes, you'll need to head toward the E at the bottom. From there, you can spiral around to the goal. All right, so here I guess this is a diagram of the path that you are following. All right. In the above diagram, the symbols indicate where the path exists. Is this a typo? Exits each square moving up. Okay, the path that I took exits each square moving up, down, left, or right. The location that should get the best signal is still E, and dot marks unvisited square. This path reached the goal in 31 steps, the fewest possible. What is the fewest steps required to move from your current position to the location that should get the best signal? Okay, and the puzzle input is quite a big map, but look at that, it actually looks kind of realistic, this height map. And here is the S, and here's the E. All right, that's cool. So this actually doesn't look like a hill climbing algorithm. It looks more of a pathfinding one. And I have done a couple of pathfinding solutions in the previous Advent of Code 2021 in Rust also. So I'm wondering if I could maybe reuse some of that. Let's go to the projects, Advent of Code 2022. Because yeah, it looks very much like a pathfinding thing, with, you know, from each square you can only move to some. Like for instance, if you're in this C, you can go to here, and also to this D, but you cannot go right to the T. So like each square has some neighbors. There's no more, like each of the movements costs 1, I guess. And in general, I guess it doesn't make sense to go down, but maybe that's not something that we need to explicitly encode. Okay, so let's get to it. Let's first parse this input. I think I'm going to try and go ahead and copy the implementation of a pathfinding algorithm that I did for the previous Advent of Code. And I think it was Dijkstra's algorithm. So okay, let's make a new file for the input, as we usually do. Let's copy the sample input first. So it would be this. All right, and let's also make a module for this. This would be hill climbing algorithm, and this is day 12. Let's copy this and make a new file called this way, and then use it. Well, actually, day 12 run, not run, and then declare the public, usually public function run, that takes an input type string and then returns string. All right, the usual stuff. And as usual, also let's reload the file to let the editor know about the tab size. I haven't yet fixed that. Okay, so first of all, let's parse this input. So what should we do? I guess we could have these heights in a vector. Let's height map be type vector of, and I guess we could use bytes for this, since they are numbers from 0, that A meaning 0 and Z meaning 26, I guess. There are 26 letters, I don't know. So this would be the input lines, then we are going to map each line to what? To line, we could do the as bytes thing, iterate over this and map each of the bytes. So this would be a character. We can, well, we're going to map it to another byte, I guess. This character, yes, it's a reference to a U8. So I guess we can subtract the byte A to get A to be 0 and Z to be the maximum height. And, or actually, we also need the starting and the start and end points for this. Okay. So let's keep. What should we do? Yes, yeah. This won't take. We also need to find the capital S and capital E on this. So I guess we could do something different here. I don't want to convert the map into a side effectful function. Maybe we can keep these bytes for now, and let's say iterator collect, or we could even do a 2vec here and collect in here. So okay, this would be, yes, the height map as characters, I guess, and we can find the S and E and modify them. I mean, yeah, that could be. That could be a solution for this, but I don't like it too much. We can also say something like, let height map be something. Let's copy this out. And let's extract this into some parse function. So we're going to have height map, start and end positions. And let's call it parse input, and just pass the input. And so then we can generate this function, and we can have this. Let this be the height map, height map. Type back of U8 again. Okay. These are just the bytes, so to this, let's have the, let's do some also. Well, now we have to find the start and end positions, I guess. We could do something like, let's start be none and let's end be also be none, and just iterate this this height map. So for first y in 0, or I guess, yeah, we could use a y and line, or row, I guess, in height map. But I also want to modify the height map. So okay. Let's think. Maybe it makes more sense to just. I wonder if I can have a map function that is a mutable function. So let's see, map. Yes, it accepts functions that are mutable. So it's kind of a hack, but I mean, who hasn't done a hack every now and then? So we can have these bytes, and we can actually iterate them and map. And inside of this map, we're gonna do some nestiness. We're going to match this character and say if it is the start position, we're gonna do start equals, and I need the actual x and y coordinates. So here I need more than the lines, I also need to enumerate them, and this would give me the y coordinates. And then here I also need to enumerate this iterator, and it's gonna give me the x coordinates. So here the start will be xy, and we are going to map to, so s is the starting position, it will be 0. Let's save, and it's complaining about stuff. Let's see what it is complaining about. Cargo run 12. Yeah, not allowed here. Okay. View from blah blah blah. Oh, we are mapping here, and we need to also collect. Fine. All right, look at that ugly nesting. And here, what's the merge type? So yes, this would be sum. Okay, so start then is being inferred to be an option of usize and usize. That's what I wanted, so that is fine. Then if it is the end, we're gonna do something similar. Whoops. We're going to mark the end as some xy, and we are going to return, what does what is the value for sed? I wonder. Guess we could do sed minus a. Let's actually see what that gives us. If we print ln, I guess it should be 26, but I'm not entirely sure. So let's do sed minus a. I just want to see which value corresponds to sed. Yeah, sure, this is a problem. Ignore this problem, please. 25. Yes, okay, because there are 26 letters, but if we start at 0, that would be 25 for the highest value. Okay, very fine. So that would be 25 for you, maximum value. And if it is anything else, I guess we could actually do some validation from A up to and including sed. Then we're gonna do this character minus A, and otherwise unreachable. Invalid character, and we put the character here. We can even do as char to have it as a character instead of as a number. Okay, yes, dereference this. Very fine. I wonder if this is a reference, but it doesn't complain about subtracting this. So, okay. Look at that beauty. And now I guess we can probably validate that start and end were found. Well, we can just return the height map and start and expect a start. Height map should have a start position. I wonder why height map is not understood as a word. Is it height map? Yes. Yeah, it should be a word. So, and I'm writing it correctly. Yes. Let's spelling. Add words to user setting. Okay. And the end also. And expect should have an end position. Okay. So we should have this thing parsed. Let's print some things. Start is gonna be a start, and end should be the end, and println the height map. Let's print it as nice debug height map. Let's run this thing. Oh, again, it doesn't. Can you infer this thing, please? Yes, you found a tuple, but can't you infer the tuple I'm wanting to return? So this would be again a vec of u8, and I guess I could give a name to tuples of two positions. Yeah, maybe I could. Let's extract the type alias for this. Let's call it a position or point. Yeah, let's call it point. All right, so it's doing all of this, and this doesn't like to be printed by default. Oh, and this height map doesn't need to be mutable. Nice. Could not compile. Cannot assign. Why? Oh, okay. Yes, you need it to be mutable. Mute. And you don't need to be mutable because we are doing the mutation on this map. Very sneaky. Okay, look at that pretty printing. So the start would be 0, 0, which I think is correct, yes. The end is at 5, 2. So let's position our cursor here. This would be column 6 and line 3. So yes, that's correct, -1. And that's it. It does look fine to me. And let's see if we find the, yes, the 25th is the end here. Great. So now how do we do the shortest path? I guess we could go to Wikipedia and search for I never know how to write the name. Dijkstra algorithm. Yes, we could go here and copy the pseudocode that we will see, but I have already done so in a previous advent of code, so I guess we can go there and check it out. So let's open the editor for this previous advent of code and go to Dijkstra, which I never know how to pronounce, and here we have an implementation of the Dijkstra's algorithm, and it also has a bunch of type parameters, and I don't really remember how I did this. So start and end are references to the type of the node that we are going to be visiting. So I guess in our case it's going to be point. That's fine. It needs to have this, implement these traits, and then we have successors, which I think are the neighbors of a given, like a function that gives you the neighbors of a. Now this is a yes. So it's a ft, which is a function from t, like a node, into iterator of items of that node and usize, so that would be the cost of visiting that neighbor. So yes, this is something that took me a while to write the previous time, and I did generalize this because there were a couple of usages from this. Yes, in 2 different days, day 15 and 23, we needed to do like a shortest path, and well, I just modularize it into a module, and now I'm glad that I did so, because I can just copy paste it and carry it to the new advent of code. So we will then see if it makes sense, if this same thing makes sense, like when does it return, what does it return actually? It returns an option of usize, so I guess it's the size of the path. And where is this return done? Here. When we know that the value is the end value that we need. Okay, so I'm happy with this. I needed to do some interesting things here that I don't remember about, like have a node and implement order and partial order and stuff like that, but let's not dig into that. Let's try to see if it works, and if it works, then I will be happy, and we can then see if we could use something more specific for our purposes here. But let's start with trying out the algorithm as it is. Okay, so how do we do this? Actually, I guess I need to import it, and I don't know if I can import it here. Mod Dijkstra. Can I import it here? Maybe not. Can't find the module, blah blah. Is it mod? Yes, it's mod. Do I have to put it in main? I think I do have to. So let's put it here. And if I have put it there, can I use it? Use crates Dijkstra. What? Well, I guess that's how you declare it. This refers to our current crate, I guess. Okay, so we need starting, end, and successors function. We already have a start and end, and this needs references to that. So let's take a reference to this, as a reference to this, and the successors function will be something that takes a point and returns an iterator, or something that can be turned into an iterator given that point. So how this would be how to get the neighbors from this point, and it's a pair of 2 usizes, so I guess we can destructure this into x and y. And how do we get the neighbors? Well, could I guess, let's think. We could have all the directions that we want to move to. So let's say that we could move to. So we could say x plus 1 and y, then that will be right. Let's start with left. But actually, we would have underflows here, I think. So I don't know if that will work. X plus 1 and I, this would be right. Then x and I minus 1, this would be up, and x, y minus, no, plus 1, this would be down. We can do this in Twitter. And then, well, I want to do some bounce checking of these things. I don't remember, I think the behavior for underflow is deterministic, like for at least for unsigned, I think they are guaranteed to wrap around. So I guess we could do then some bounce checking by a filter. So we're going to filter the positions that are inside the map. So let's do, how do we do this? Height map, I guess. We have a get that returns in position. Yes. Or none if it is out of bounds. Okay, we can use get to get the to do the bounce checking. So I guess we could do get y and then get, and then if it is in bounds, and then yes, and then this would be a row. We do row get the x coordinate, and I guess instead of doing filter, this would be a, we could think of this as a filter map. So in this, I think, if I'm not mistaken, this would be none if we are out of bounds, and it would be the value of the height if we are in bounds. So what are we missing here? This is the filter map, and gets to say like shortest path is this. It is complaining about, oh yes, this arrow. And what am I coding in JavaScript or something? Okay, so here it doesn't like some things. Yes, we need to dereference these things. So can I dereference them like this? Yes, indeed. So for the underflows, I am thinking that if they do wrap around and get to be very big numbers, then it's fine to do this. But otherwise, if we get an underflow error, we have to fix that. But then after that, we also have to filter. Oh, we need to know if we can move there, right? Yes. So how do we do that? Because we no longer have the, no, we actually do have the x and y here. Yes, so we have mapped to the value, the height value of the neighbors. So I guess we could also get the height at this current xy. So I guess we could say xy height. This is a terrible name. That's okay. Height map y and x. Yeah, let's call this thing I don't know. Well, yeah, let's call it x squared y height. And here we're mapping to the neighbor's heights, so we want to filter those neighbor heights that are at most one higher than us. So how do we say that? Neighbor height, let's say +1, or I guess height is so we can move if they are at most one higher than us. So how do I express that? I always get confused by this. Yes, neighbor height must be less or equal than our height +1. Okay. And xy height is u8 and neighbor height is double reference. So let's double unreference this. And yes, this thing actually expects to have, so here we have nodes. We have to map these nodes to the cost. So I guess we need a final map. No, actually here we are I made a mistake. So here we are filter mapping, and I don't think I want that. What I want is to keep the points. Yes, keep the points. So I guess we are doing too much mapping here. Let's express this as a single filter, right? So, whoops, we have this, and what is this? Here we're doing the bounce checking, I guess. So I'm very tempted to do like more manual bounce checking and put all of this in a single like a single expression. But okay, we can do this. This is bounce checking, and then we can just simply ask if it's sum, right? Yes. And then we can filter this neighbor x and y's. So we're gonna have, instead of neighbor height, we're gonna have a neighbor x and the neighbor y, and we're gonna map. We're gonna say let's neighbor height be the height map at y and x, and here we are filtering by the heights, right? Right? I think so. Yes. And of course here we don't need to do all the super double unreferencing, and I mean this, we don't need to be getting these things because this expression is not really doesn't look very nice, to be honest. We can actually check if let's say, can we ask something like index just simply y less than head map len, and x is less than height map 0 len. And we could actually okay, I guess we could actually even extract these things into variables. Doesn't know. Let's say height map height, which is very which is very confusing name. Height map height. Yes, I'm gonna stand by it. And this is gonna be the height map width. All right. All right, here we have filtered the out of bounds things, trusting that underflows are gonna be made. And then we are filtering by the rule that we cannot go more than one higher. So the neighbor height must be less than or equal to our height plus 1. Very good. And we finally need to map these things, these neighbors, for point to their cost, which will always be 1. So here we have a problem. Borrow problems. Let's see if we can understand this. Yes, we can make this thing move. No, the move doesn't go there, it goes here. No, I opened another code. Okay, cargo run 12. Move of height map occurs here. No, I don't want to move that. So can I like deborrow here? What's up? This thing may outlive, this closure may outlive XY height. And can't you just copy it? Of course, also this, I made a stupid mistake here. We need to use the neighbor X and Y to access this here. Can I run again? Yes, you may outlive this, but what's the problem of doing so if this borrowed here, but this is just a U8. Can't you copy it? I don't have a very good model of closures and moves for this kind of thing, so I think I am just trying stuff at random. Yes, you are capturing this thing. Okay. But can't you like not move? I'm tempted to go to our previous project and see how this distra thing was used. So let's actually search for that. Searching, initializing the Rust server, I guess. We could also do shortest. Wow, there it found it. So let's see. Okay, neighbors. Well, there is some moving going on here. well, it did a very similar thing to what we were doing before, but here it does this thing transform to signed integers, fine. Then does the bounds checking, fine. Then does the mapping, and it is maybe we can extract, as it was done here, we can extract the closure and make the closure live a bit longer. Maybe that's a good idea, I don't know. Extract into variable, so this would be neighbors. Yes. A type annotation is needed. That's another thing. Cannot infer the type of this. Why not? Isn't y a usize? And isn't height map something you know what it is? So let's see if you have this, can't you infer it? No. What the hell? Do you need wait, if I don't borrow this, that's another problem, right? Type is match, cannot infer type, blah blah blah. If I say here as usize, are you happy? Yes, you're happy. Well, we can maybe say that this is a point, and I guess I need some referencing over a bound introduced by this code. Okay, can it be a reference to a point like this, and like, well, now it doesn't complain about this, but it does complain about the same problem as before. Okay. Actually, let's take a look at the other thing we were mapping. Yes. Here we're not mapping to... Oh yes, there is map. So there was even a cost associated here, but here we don't need a cost for this. So what is our living watts? I mean, can I understand this problem? Closure may outlive the current function, but it borrows xy height, which is owned by the current function. Yes, okay. Yes. Okay. So if I inline this here, will you be happy? Well, now closure may outlive the current function, but it borrows a y, which lives in here. Okay. Let's undo that. Let's maybe try to define this as a move. Okay. Maybe we are closer. This function implements fn once, not fn. Okay. So I guess this is because this shortest path wants the function to implement fn. Maybe we can say fn mute, because once is going to put more restrictions on, over that. This function is implementing fn once because it's taking ownership, I guess, or it's moving the height map into it, I think. How were we doing this before? It was a reference to a vector. Now I see this as not very convenient because I'm not passing a slice here. But I mean, maybe it is more useful if we do let's height map ref be. This sounds very stupid, but let's try it. This thing, and here we use this height map ref instead. What do you think then? It's the same problem, right? We can undo what we did here. Okay. Are you taking height map somewhere else? Oh yes, here. So can we use the height map ref again? Oh, okay. Now it compiled. Or I guess type checked. Damn. I should understand this better. Like, when are things taken by reference and when not? Like, is what we did the same as saying height map as ref? This returns to the shared ref of the usually inferred blah blah. Would you be happy with this? Using a fully qualified path. Okay, maybe not. I don't understand why. Like, I guess, okay, this closure was taking ownership, I guess, of the height map by using it. And so what? Isn't that like a shared reference? No, it was a move, right? I had to understand that better, to be honest. But okay, let's run. And well, there was a panic. Subtract with overflow. Yes, okay, so the subtracting didn't really work. We could, I guess, do wrapping sub. Yes, we can subtract 1, and here we can subtract 1 also. Wrapping sub 1. It now doesn't read as nice as in the -1 case, but okay. Let's ignore that for a second. And actually we need to print the shortest path, so let's actually print it here. No, not print, format the shortest path. What's your problem? Oh, this is an option, right? Yes, let's expect this thing. Expect. There should be a path from start to end. Okay. Now what's invalid formats? Yes. Okay. All right. 31. So after a lot of fighting with types of things, we got the answer with the power of using an existing algorithm. That's very nice, but that is the answer for the sample case. Let's copy the actual input. And let's close this other advent of code. Let's copy the actual input, save and run. Okay, 383. Does that make some sense? Well, this is 68 columns wide, or 67. So maybe this seems like a very long path, but I don't know. Let's try it out and see. Maybe it took a very winding path. Okay, that was correct. Very nice. Maybe a good exercise could be to print that that path over here and see which was the path that I was taking. But let's see part 2. As you walk up the hill, you suspect that the elves will want to turn this into a hiking trail. The beginning isn't very scenic. Okay, maybe we will have to print things. The beginning isn't very scenic though. Perhaps you can find a better starting point. To maximize exercise while hiking the trail, you can find a better starting point. While hiking the trail should start as low as possible, elevation A. The goal is still the square marked E, however, the trail should still be direct, taking the fewest steps to reach its goal. Okay, so you'll need to find the shortest path from any square at elevation A to the square E. Again, consider the example above. So we have this. Now there are 6 choices for start position, 5 marked A plus the square marked S. That counts as being at elevation A. Okay, yes. If you start at the bottom left square, you can reach the goal most quickly. So if we start from here, we can, okay, this path reaches the goal in only 29 steps, the fewest possible. What is the fewest steps required to move starting from any square with elevation A to the location that should get the best signal? Okay, so I guess we can consider any elevation A from here. Okay, so this, I guess we could use a brute force solution for this, like try any square at elevation A and see its shortest path, and then take it the minimum of that. But it does seem a bit wasteful, because like the distress algorithm is calculating the cost from, like, it's already calculating most of that. I guess we could do sort of an extended Dijkstra thing that calculates the cost of the cost for everything on the square. But well, let's try the brute force first and see if it's taking too long. So what do we want? Well, let's do this with shortest path from start. And of course, this didn't rename the print statement. Okay. Let's try to do this with using iterators again, just as we did here, and we got this beauty. Actually, I really dislike this thing. I probably will try to change this into two for loops with indices that I think will fit better. But well, so let's say we want the shortest path from any shortest path from any start, let's say, or from any bottommost point. That's a mouthful of a variable name. But okay, let's see. How would we do this? We could get the height map lines. Come on. Here we'll have. Well, actually, let's do a simple for loop. Yeah. Yeah, so we have this. We actually could start from the shortest path from the start. And let's say a for from y in 0 to height map height, then for x in 0 to height map width. Oh man, this height map ref is horrible. I need to understand why didn't the previous advent of code didn't suffer from this, because we already had like a reference. So okay, I guess we could take a slice, maybe. I don't know if that will improve anything. Like, what is height map slice now? Yeah, it's a slice of x. Not the best, so let's keep it as a ref and deal with it. Okay, so here we are iterating every point, and if the point, so if height map at y and x is 0, this is the bottommost point, so let's take the shortest path is going to be this. And we need a start and an end, actually. The end will still be the same, but the start will actually be x and y. This x and y. And let's say the shortest path from any bottommost, I guess bottommost, is that a word? Yes, it is a word, it seems. It's gonna be the minimum of this and the shortest path that we got now. Look at that beauty. And this can be mutable. It should be a usize, okay. And let's print this humongous variable name. Cargo run. Well, panicked. There should be a path from start to end, so some of them might not get shortest path. That's okay. We could, I guess, say if let some, if there is a shortest path, then we're gonna do this. Otherwise, not. We can run, and it's taking that one took longer. 377. Would this be the correct answer? I don't know. I'm not trying with sample input, but that one took longer. Okay, yes, we did get a golden star, but at what cost? Actually, at what cost? We can time it, and it's taking its sweet time. Well, 1.9 seconds. I guess if we do a cargo build release and time the target release advent of code blah blah day 12. Well, actually, if we build in release, it's still taking 0.16 seconds. So yeah, 162 milliseconds. It's not too bad. Well, we got a golden star, so that's nice. It didn't take us too long. That's mainly because we have reused the distress algorithm from a previous solution. But if you take a look at this distro solution, we have the distances from any point to the end in this hash map, and we, like, when we calculate it, presumably when we calculate the shortest distance from one starting point to the end, we're also calculating a bunch of minimum distances along the way, but then we are throwing all of those out to when you know, for the next calculation. So this is very inefficient what we are doing here. We could probably do I don't know how it is called, but like a greedy distra that calculates the distances to the end from any point in the map, and I guess they could start being like, they could be initialized as being like infinite or something like that. I wonder if, yes, we are using usize max here to represent the infinite starting points or starting costs. So yeah, I'm pretty sure that we can probably optimize this quite a bit, like doing some nice algorithm work. But I think I will leave that for a future session and future video, because I had to do other things today, and I don't want to spend a lot of time like optimizing right now. We have already gotten the 2 golden stars, so I'm happy with that. Let's try to improve this kind of horrible solution though. So there's a couple of things to improve. The one that I'm most like, the one thing that I like the least in here is this height map ref. Like, I'm pretty sure that I'm missing something here. Like, shouldn't closures take things by reference by default? And also here, did we finally need this move, or wasn't it necessary? Yes, we are needing it because of the XY height. Okay. Here's what call it cur height for currents. Fine. And I wonder also if it would be better to just use signed integers for these points. Maybe. Okay. So what do we want? There's a couple of things maybe that we could improve here. Sorry, I'm being a bit fussy today. So let's take a look at well, maybe this neighbor functions is something that I'm not too fan of. We could maybe extract it because yeah, here we're using these neighbors twice. We could maybe extract this minimum shortest path thing. So, and if we do that, we can take a reference to to the height map, and yeah, I guess. Sure. So let's do that. Let's extract almost all of this. Can I, if I extract this into function, what do you do? Well, it does kind of a mess, but not so much of a mess, I think. Well, no, actually it did. Let's do it by hand. So we're going to do this in a function that's called shortest path, and I don't know exactly what we're going to do, but let's just return the dexterous shortest path, and this is not guaranteed, so let's keep it as an option. This is going to surely return an option of usize. Good. What will it take? Well, it's going to take the height map. So height map, I guess, should be, I would like this to take a like a slice of slices. I don't think I'll be able to do that. Let's remove this height map ref and use the height map like this. And we need the start and end. Yes. Start. Well, yes, start should be a point reference, and end should also be a point reference. Very good. And neighbors doesn't like it because cargo run 12. Closure arguments. Now I guess we are passing up double references here, so let's not double reference. Okay, so we have extracted this. Let's use it now. Just say shortest path, and we're going to pass things around in another order, like this, I guess. Actually, no, we're not passing the neighbors, we're passing the height map. And we don't need the neighbors function here. We don't need any of this. And can we take a reference to this? Probably not, because yes. Let's see if there's actually a way to Rust converts vec of vec to ref slice, something like that. Well, I don't think I can get actually a slice to slices because we don't have that. We don't have any data structure of that sort, so I guess we can take this thing, a reference to a vec of U8. And this should still work the same, yes. And this should now work, that's fine. And oh, we need height map height and width. Actually, maybe we can get rid of this, but yes, so here instead of doing this, we could probably do a row in height map iter enumerates, sure, and then x and height, you can do row iter, same thing, enumerates. Height should be, well, these are references. So here we can ask if the height is 0. Then we do stuff, and we can actually call shortest path using this height map, passing a reference to this. This will be the start, and the end will be still be the same, and we don't need the neighbors function. So what now? We need to pass a reference here. Good. Oh, very good. Let's run again. It's taking its sweet time. We get the same results. Okay, so we have extracted a little bit of the logic. So I guess, yeah, these variables are fine, I guess. There are some things in here that I'm not a total fan of. So what are we doing? We're using this let's see how we were doing this in the previous advent of code. I am a bit curious how we solved this out of bounds checking, because I guess the problems were pretty similar. So we got the directions, we iterated over this, then we mapped to the points, and then we filtered the out of bounds things. Yeah, that doesn't sound too bad. Can we do something similar now? I guess so. But this is also not so bad, I guess. Well, I don't like maybe this wrapping sub and some of these. Yeah, we could, I guess, try to. We'd also convert this to i32s and not care about these things. Let's see. What are the alternatives here? Or we could let's actually try to start with that. Well, let's add these changes. and C. Here we are basically doing -1, 0, then +1, 0, then 0, -1, and 0, 1, oops, to get the neighbors. So to do that, we can map these things dx and dy to these x and y's, so x plus dx and y plus dy, but here we want to use sign arithmetics, I guess, and check out of boundnesses. So we can do something like what? So here dx and dy are u size, but they shouldn't be, right? Because this is like a -1 thing. Well, let's say wrapping add signed the x and wrapping add signed dy. Why don't you like this? No, it doesn't. Shouldn't take 2 arguments. It should take 1. What's the problem? May outlive y. Isn't y, well, just the u size? Well, you're happy now, and keep going up once more. Okay, so this also works, and it's a little bit more compact, I guess. Here we are explicitly doing wrapping add signed to go, like, make the underflow go out of bounds, and then here we are checking those bounds, I guess. Sure, this could be something. And then we are doing this. Yes, we can also call these things x and y, as we were doing just above this. It's enough to call this the neighbor height, and yes, I think this is fine for the shortest path thingy. So let's add that. This is the shortest path from the start, and this mouthful of a variable for shortest path from any bottommost point. Sure, it's very descriptive, so I'm okay with it. We are iterating over all the height map, and if the height is 0, then we are taking the shortest path, and if there is a shortest path, then we are taking the minimum of those two. Okay, yes, I'm okay with this code, even though some variable names are a bit verbose. I'm okay. And let's see the parsing, because the parsing is, questionable, I guess. I guess one thing we could do, let's think. We could have the lines. Let me think and think and think. Yeah, it's just sneaky to do some changing of a mutable variable inside of a like nested map thing. That's a bit too sneaky, I think. Yeah. How could we do this in a less horrible way? I guess we could do the height map first. Well, let's think. It's not too bad actually, but we could do the height map first and then calculate the start and end, like reading the input again, I guess. That's also another possibility. So, yeah. Let's see, if we do, for instance, let lines be vector input lines and collect, and then let's do the height map right away without doing these modifications of stuff. I guess this could be lines iter enumerate. Well, and we don't need the x and y, so we don't need to enumerate twice. We don't need, well, the thing as bytes, I guess we still need it. This is not a tuple, and this is not a tuple either. Okay. And I guess so far this is a tiny bit better. Instead of as bytes, I think there is a bytes function that is already an iterator. We don't need to even do this. Sure. We are mapping bytes to bytes here. Okay, so let's say we have that. Then can we find the start in the lines, like lines? Find. But we're going to need to enumerate over this, right? Going to find the line where it is, and then for each line we need to find the x and y coordinates. Let's think. Can I express this in a nice way? Man, today I'm a bit like I'm not thinking very clearly. I think I should probably stop with this session and continue on another day. Yeah, but I'm curious now to find this thing. Sorry, I have my cat asking for to open the door. Let me stop there. Okay, I'm back. My cat was calling me to open a door. Okay, let's see. How do we find these things in the text? I guess another way of doing that would be to, well, find the line that's, this would be line and line index of, isn't there an index of or something? An indexing operation. Hola. So yeah, my cat wanted some pats. Char. I guess since strings are UTF-8 internally, getting the index of something is not so straightforward. So I guess, yeah, you can do chars position. Okay. Oh, there's a find. Okay. So line find. Yes, okay, and it returns an index, I guess. So we are looking for the S here, and this will give us the X coordinates, sure, if it exists, and yeah, I guess we could do something like that. But I don't think that is more readable than what we are doing. So we can probably think, I'm probably thinking of doing this in a more like imperative way. I'm very tempted to do so. Yes, why not? I mean, now this mapping is fine. We even did invalid character. So okay, now let's. Today I am being. I'm not thinking very straight. So let's undo, discard these changes that we were doing right now, and keep this mutable map, which is a bit horrible, but let's take a note of this. Hack sneakily mutate some outer variables inside the map. Yeah, not very cool to do, but it works. And we do have the two answers, although they are taking their sweet time to compute. So, okay, that's it for today. I'm thinking quite fussy, so I think I should call it quits now before I start making any sense at all. So if you have been, thanks for watching and see you next time. Well, I should commit first, so let's simply say day 12 solution. Yes, and that's it then for today. See you again next time. Bye bye.